orthocenter of a triangle is the point at which the altitudes of a triangle intersect. If the triangle is obtuse, the altitudes will intersect in the exterior of the triangle. To construct the altitude, we need to remember that the altitude of a triangle is the perpendicular segment from the vertex to the opposite side of that triangle. To construct the first altitude, I'm going to take the compass, put the point at the vertex, and open up the compass enough so that I can make two small arcs along this side. Now I'm going to take my compass and I'm going to put it on each of those points of intersection, and I can adjust the compass. I can open it or close it further. What has to be true is that it has to be over halfway between the two intersecting arcs. So with that in mind, I'm going to draw an arc from one side, then I'm going to draw an arc from the other side. I'm going to take my ruler and connect that vertex with that point of intersection. And this line is perpendicular to that side. Now we'll do the other two altitudes. The point where these three altitudes intersect, right here, is called the orthocenter. Now I want to show you what happens when you have an obtuse triangle. The altitude from the vertex of one of the acute angles to the opposite side is going to be a little bit tricky to construct, because if I try and draw a perpendicular from this point to the other side, notice that I'm outside of the triangle. So what we need to do is extend that side of the triangle so that I can get my altitude. Well, the first thing you need to do is extend the side. I'm just going to use a fine line, and now I'm going to do the same thing that I did in the last example. I'm going to take my compass, I'm going to mark off an arc on both sides of the compass. Now if you don't have room on your paper, you can certainly change the compass. Just make sure that it's obviously more than halfway between your two intersecting arcs. Now let's construct the other two altitudes. Notice that all three of those altitudes had to be extended to find the point at which they all intersect. This point is called the orthocenter. The orthocenter for an obtuse triangle will always be outside in the exterior of the triangle. The centroid of a triangle is the point where the medians of the triangle intersect. The median of a triangle is a segment extending from a vertex to the midpoint of the opposite side. In order to construct the median from this vertex to this side, I'm going to need to know the midpoint of this side. And the only way that I can find that is by constructing the perpendicular bisector. Remember that when we construct the perpendicular bisector, we need to make sure that our compass is open over halfway between the two endpoints of the segment. Then what we do is we draw an arc below and above each of those endpoints. Now I use a ruler to connect those intersections. I'm going to draw this with a dotted line because it's not really the perpendicular line that I'm interested in. I'm just interested in this point right here because this is the midpoint. Now I'll do it for the other two sides as well. Now you may notice that these three perpendicular bisectors all intersect at this point, and this point is called the circumcenter. But the circumcenter isn't really what this video is about. It's a byproduct of constructing the perpendicular bisectors, but what we are really interested in are the three midpoints, here, here, and here. So now let's use our straight edge and construct our medians. Here's our first median. I'm going to use a thicker line just so that we can clearly see what the medians are and not get them confused with all of the other marks on the construction. Notice that I have gone from the vertex to the midpoint of the opposite side. And now I will draw the other two. All three of the medians intersect right here at a point that we call the centroid. The centroid will always be in the interior of the triangle. The circumcenter of a triangle is the point where the perpendicular bisectors of each side of the triangle intersect. It can be in the interior or the exterior of the triangle. To find the circumcenter of this triangle, we need to construct the perpendicular bisectors of all the sides. If you need help with perpendicular bisectors, please watch the earlier posted video. I've done all three perpendicular bisectors in different colors so you can see the marks that go along with each. And the point right here in the center, this point right here, is the circumcenter. Now the reason that it's called the circumcenter is because it is the center of the circumscribed circle for this triangle. So if I put the compass point on the circumcenter, I can circumscribe a circle around the triangle. I want you to notice on this one, because it's an obtuse triangle, the circumcenter is actually outside the triangle. Let's see what the circumscribed circle looks like. Even though part of the circle is off the screen, you can still see that you do get the center of the circumscribed circle. The incenter of a triangle is the point at which the angle bisectors intersect. The incenter is the center of the inscribed circle of that triangle. To find the incenter of this triangle, we need to bisect all of the angles. If you need a review on how to construct the bisector of an angle, please watch an earlier posted video. I've constructed each of the angle bisectors in a different color so you could see the construction marks. And this point here is the incenter. Now the reason it's called the incenter is because it is the center of a circle that is inscribed in the triangle. Now the problem is I can't just take my compass and put the center here and just kind of eye it. I can't, I can say, oh, this looks kind of like the radius, we'll use that. You can't do that because that would not be a construction. So what we have to do is we have to construct the radius, which is the perpendicular segment from the incenter to one of the sides. To construct a perpendicular segment from the incenter to one of the sides, I need to take my compass and I need to mark off 2 arcs. Put it on each of those points of intersection, and I'm going to draw an arc below from both of those points of intersection, and that intersection of those 2 arcs along with the point will give me a perpendicular segment. So I'm going to draw the perpendicular segment, but I'm just going to make this dotted below here because I'm not really interested in the full perpendicular segment. I'm really just interested in this much from the incenter to the edge because that's the perpendicular part that will give me the radius. So to finish my circle, I'm going to take my compass, I'm going to put the center at the incenter. I'm going to adjust the compass so that it measures the length of my radius, and I'm going to draw my circle. The circle that I draw is called the incircle because it is inscribed in that triangle. And now as a final comment, the incircle will always be in the interior of the triangle.